Hello, hi everyone, welcome back to the channel. So today in this video lecture we'll be solving this problem magic ship, and this is one of the interesting problems in binary search. And let's read the problem statement. So you are a captain of a ship. Initially you are standing at a point x1 y1, so it's the initial point on which you're standing. Okay, now you know the weather forecast. That means there is a string of length n that represents the weather forecast, which consists of letters U means upper, D down, L left, R right. That means the letter corresponds to the direction of the wind. So U means the wind goes up, the wind goes up. D means the wind goes down. L means the wind goes left, while the R goes that the wind goes right. Moreover, the forecast is periodic. That means not only these directions, but the forecast is also periodic. That means the first day wind blows S1 side, the second day it blows S2 side, and on the nth day it blows Sn side, while on the n plus 1th day the wind blows on S1 side again. So that's okay, so it's a periodic forecast. Now the ship that we have, which is initially standing on x1 y1 and want to reach this point x2 y2, moves in the following way. So if the wind blows the direction u, so if the wind goes in the upper direction, then the ship moves from x1 to xy plus 1. So let's take a coordinate system. So this is a coordinate system, this is a direction y, this is a direction x. Okay, now so these are the direction vectors. It u, this is d, and this is l, while this is r. Okay, so in this fashion the wind basically moves. So if the wind blows up, okay, then let's say the ship is at this point, this is xy, then the ship will move to one position upwards. It will move to x y plus 1 here, x y plus 1. If the wind blows in the downward direction, that is this one, then the ship goes downwards by 1 unit, that is to x y minus 1. The y coordinate decreases by 1. If the wind blows towards L, that is towards this direction, then the ship moves from xy to x minus 1 y. Okay, that means the ship moves towards the left direction by 1. If the wind blows towards right, towards this direction, then the ship moves towards the right direction by 1 unit. Okay, so in this fashion the ship behaves. The ship can also either go one of the 4 directions or stay in one place each day. Okay, now that means this string S basically defines the motion of the given ship according to the wind, while the ship itself has an engine. That's why it can move towards one of the 4 directions in at any day. Okay, due to its own power, because of its own power, consuming its own power and resources. So if it goes, then it exactly covers 1 unit of distance. Okay, transpositions of the ship and the wind add up. Let's say the ship wants to move towards right, while the wind also is blowing towards right. So 1 unit due to wind, 1 unit due to ship itself will give me 2 units of displacement of the ship towards the right direction. So in this fashion the ship moves according to the wind and according to its own power. Fine. Now if the ship stays in place, let's say the ship does not want to move due to its own power. It just sees its engine. In that case, it just moves according to the wind. For example, if the wind blows to the direction u, if the wind blows in the upward direction, and the ship moves to and the ship moves towards the direction L, that is, the ship moves in this direction here, while the wind moves upwards in the upward direction. Then from xy, the ship will move to x minus 1, y plus 1. Fine. That means 1 unit towards left due to ship itself, while 1 unit towards upward direction due to the wind. Okay, so that's how the ship moves. The ship basically moves due to two forces. The one force is the force of the wind, and the second force is due to its own engine. Okay, and what do we have to do in this problem? We have a destination location given by these coordinates x2 and y2. Our task is to determine the minimal number of days required for the ship to reach that destination point if the ship starts from x1 and y1 and it moves according to the strategy which I explained here. Okay, we just want to know the minimum number of days which the ship takes to reach its destination location. Okay, the input will be given two integers, that is the destination location, two integers, that is the initial location or the starting location, two integers or the coordinates of the destination location, and an integer n representing the length of the string s, that is the forecast string, and finally we have the string itself s representing the forecast or the weather forecast more precisely, which has these characters u, d, l, r, according to which the wind blows. Okay, so in the output we just have to print a single integer representing the minimum number of days required for the ship to reach the destination point. Okay, so that's the problem statement. Let's better understand the problem statement using an example. Okay, so let's understand the problem statement using this example. So we have our initial coordinates as 0, 0. We have our final coordinates to be 4, 6. Let's plot these coordinates over a Cartesian plane. So this is our Cartesian plane. This is x direction, this is y direction, and this is the navigation according to which the ship will move: up, down, left and right. Okay, now the ship is standing over here. The ship is standing over here. 0, 0. Now this is the position 4, 0. Okay, finally we have these coordinates, that is 4 and 6. So I want to reach this position 4 and 6. I'm standing on this position A. Let's call it A. Let's call it position B. Okay, this is my forecast string S, weather forecast string. Fine. Now what would be the minimum number of days to reach this position if we start from this position A? Let's see that. Now according to this forecast string, in 3 days I will be present at I will reach at this position, that is 1, 2, 3 here. This position is 0, 3. I would take exactly 3 days to reach this position. Now while I know that I want to reach the position 6, I want to reach the position 6. Okay, And okay, so in 3 days, if I follow this string exactly, I'm gonna reach this position according to the weather forecast. Now let's say that in these 3 days ship, we can also move our ship as well. So what would we do is, in these 3 days I would move my ship towards right direction. Okay, so on the very first day the ship will move right by 1 unit, so the ship will move right by 1 unit, while it will move right by 1 unit due to its own power, while it will move 1 unit up due to the wind's power. So this is the position of the ship after the first day. So let's call it wind power. So according to the wind power, or the okay, let's call it ship power or ship's engine, due to which the very first day it is going to move towards right, and this will be the position, that is 1 1 after the first day. In the same fashion, it's going to move 1 unit towards right on the second day due to the ship's own power, 1 unit towards up due to the wind's power. This is the location on the second day. On the third day, same, 1 unit due to ship's power, 1 unit due to wind's power. Fourth day, again 1 unit due to ship's power, 1 unit due to wind's power. So here is the location. This location is 4 and 4 and 4, and I have taken 4 days at this point. Okay, now since I have taken 4 days, on the 5th day the wind will blow towards upward direction. So the wind will blow towards upward direction. So what I would do, I would simply move the ship due to its own power in the upward direction as well. So so it will move exactly 2 units towards upward direction. 1 unit due to its own power, 1 unit due to the wind's power. Okay, so 1 unit due to its own power, 1 unit due to the wind's power. So finally, on the 5th day, I will move 2 units towards upward direction. So every day I am basically moving 2 units, 1 unit due to ship's power, 1 unit due to wind's power, and the ships and the directions due to ship's power would be like R, then R on the second day, R on the third day, R R R R, R on the fourth day, then up on the fifth day. So in this fashion the ship will move itself, R R R R up U, and it would take me exactly 5 days to reach the destination point, that is this one, and that's the answer. Fine. So we have basically two forces working, one due to the ship and another due to the wind. We can also choose to not use the engine's power and just go with the flow if it gives me the minimum number of days. But in this case we had to use the ship's power to reach the destination as soon as possible. So we used it. Now how can we solve this problem? Let's think about it. So we start from some location, starting location, let's say xy. We want to reach this x2 y2, and this is the forecast thing that we are given, and we can move to any direction in one day due to the ship's engine, using the ship's power. So upper, left, right, down, in this fashion. Now I want to reach this destination starting from the initial location 0 0. How can I do that? Let's see. Okay, so let's solve this problem. Okay, so the strategy to solve this problem is simple. We can see that, observe that, since this is a, again, we can see the pattern here. What do we want is, we want the minimal number of days such that we can move from the initial position this one to the final position this one. That's the basically problem statement says. So let's say we take x days to reach the destination starting from some source position. These represents the minimum days to reach it, to reach the destination. If we can reach the destination in x days, we can always reach the destination in x plus 1 days. We can always reach the destination in x plus 2 days. So what I'm trying here, I'm trying to binary search over this answer, because the number of days is the answer and we want to minimize the number of days. Okay, and on the right extreme, the maximum number of days can go up to, days can go up to, let's say we have, let's say in the worst case we start from the position 0 0, because we are just here you can see that we can just move on the positive side. So we, in the Cartesian coordinates, we just stay in this quadrant. We never go to these quadrants while navigating our ship. We just stay in the first quadrant, this one, or we can say the positive plane. X is also positive, y is also positive. Now let's take the worst case when we start from this origin and we want to reach some location, let's call it x and y, and let's take the extreme location which we can reach. The extreme location is, let's say we have x to be 10 raised to the power 9 and y to be 10 raised to the power 9, and in the worst case we may take 10 raised to the power 9 plus 10 raised to the power 9, that is 2 into 10 raised to the power 9 steps. So this is the upper limit, 2 into 10 raised to the power 9. So let's write it 2 into 10 raised to the power 9 to be the upper limit. While we can't reach the destination in x minus 1 days, we can't reach the destination in x minus 2 days, and so on. Let's say 0. 0 is the left extreme because maybe the destination and the source are the same. Okay, in that case we just don't have to move, and it doesn't take even a single day to reach the destination. So this is my search space. We have my search space 0 to 2 into 10 raised to the power 9. We just want to find this x, that is the first true, because these are the good days, let's call them good. These are the bad days, let's call them bad. Okay, so let's find the, so we want to find this x. We just have to binary search over this answer x. So we have the lower limit, we have the upper limit, just binary search, find some middle element, let's call it mid, check if it lies on the good side or it lies on the bad side. If it lies on the bad side, that means the range will be reinitialized to mid plus 1 till high, because the answer lies in this space, while if it lies on the good side, then the answer lies from low to mid minus 1. In this fashion. Now that's all. Now the main challenge here is basically to find out if we can reach the destination in the given mid, if this mid lies on the good side or it lies on the bad side. Fine. How can we do that? Let's see. Now we can see that we have this forecast string. Now we have the number of days which we have predicted. Just find out the final location which we can reach or the ship can reach if it just follows this forecast string. Just follow this forecast string, just follow the wind, just go with the flow for mid number of days and check out the final location in which I can reach. Let's take the mid that we have guessed is 5. Let's say the mid we have guessed is 5, and this is my forecast string, and in the 5 days I would be moving towards upward direction 5 times. So 1 2 3 4 5. I would be here, my ship would be here. If I just follow the wind, I have 5 days. Now make all I have to make sure, this is, let's say, some temporary location, let's call it XY. Now all we have to figure out that in those 5 days, what should be the strategy for our ship to move such that we may end up at the final location. We can see here we have 5 days. In 5 days we can move our ship towards right direction, because we have to reach this one, we have to reach position number 4 towards right. So just move the ship towards right direction, of course, because of its own capacity or its own engine, its own power, because the wind simply takes the ship towards upward direction. So due to ship's engine, I will move in 5 days. In 4 days I will move towards right, so I will end up here due to the ship's power here in 4 days, while in 4 days I would be here due to the wind's power here. That means in 4 days, if I find the resultant vector, I would be at this position. That is my resultant vector. I would be at this position. This is the position of the ship after 4 days. It is 4, 4. Now on the 5th day, I know that the ship is going to move towards upward direction due to wind, while due to the ship's power, the most optimal move would be to move it along the upward direction, because we have 2 units to travel to reach the destination point. So I would move the ship towards upward direction, hence 1 unit due to its own power and 1 unit due to wind's power. I will reach the destination point. So in 5 days I can reach this point. So that's how I am going to validate the given number of days. That means this 5 lies on the good side. If I couldn't reach this point in these 5 days, then this 5 lies on the bad side. So in this fashion I will arrive at the answer using binary search. Very simple problem. Let's implement it. So this is a minimal day function which takes in this initial location x and xy, sx, sy, ending location ex, ey, and the forecast string. This is wm string basically represents the let's call it maybe navigation string, or the string representing the directions towards which the ship can move. The ship can move towards upward direction, downward direction, left direction, and right direction, like similar to east, west, north, south. Okay, that's what this string represents. Now these are the 2 direction vectors. These will be used to actually navigate to the adjacent points. So if I want to move to, let's say I'm standing on some point x and y, I want to move to 1 unit upwards, I would choose this pair. I would choose this pair, because adding 0 to the x, adding 1 to the y is going to give me x plus 0, y plus 1. The new location. If I want to move 1 unit downward, then I will choose this pair. That means 0 units towards x, x plus 0, and minus 1 units towards y. So while if I want to move in the negative x direction, then I will choose this pair, because this is going to move the ship towards left direction. So x minus 1, y plus 0. If I want to move towards positive x direction, I would choose this pair. This is going to give me x plus 1, y plus 0. So that's why I'm using these direction vectors. This is the pair. This is the basically an array which stores, let's say, for any position n. So for all of these, so what this basically stores, that after n days, after, let's say, after I days, the final position of the ship would be di. This is the final position. That's why I'm using this array. So this di is nothing but a pair representing the final x coordinate and the final y coordinate, while n is the length of the string, this forecast string. Let's iterate over the number of days. We have n days. So this is not, let's not call it index, let's call it id. So id represent -1. So this id is basically going to figure out in which direction I have to move on the particular ith day. So we have n days for every position in this string, forecast string, and for every day I just want to get the corresponding id in this direction vector, which represents the direction in which I have to move. So I will iterate over all of these 4 directions. Okay, in the 4 directions, that is this string. If I find let's say the ith position of this string si resembles with this first position of the navigation string, here direction string in other words, that means I have to move upwards. And corresponding to that direction I have this pair 0 1, 0 in the x direction, 1 in the y direction. So that's why this id basically represents the j, the position corresponding to this vector. So the id will only store either 0 1 2 or 3 corresponding to the location of these pairs. Okay, so finally, after we have checked the direction on the ith position, we have to move our ship towards that direction. So currently I'm standing on the ith position. I want to move to I plus 1th position. So from the current position I will move dxid units towards x direction, while I will move dyd units towards the y direction. Okay, so simple. This is going to store the position of the ship after the ship has moved towards the direction which this position represents, this position in this weather forecast string. That's the purpose. Okay, let's just see the next slide. Finally, in the position this dn, what this will represent, this is going to represent that after n days I would have the position of the ship to be this one. If we just follow the wind, here I am just following the wind. So here I am just following the wind, I am not following the ship's engine, just calculating the position of the ship after n days, which is present at this location of the array. Now let's initialize 2 boundaries, left boundary and right boundary, and perform the usual binary search. Find the middle element, find the number of cycles. That means this I'm just guessing the number of days which the ship will take to reach the destination. Now in those days, here I am just calculating the number of cycles of this forecast string that I have to make. Let's say the forecast string is something like urll, something like this, and the days are, let's say, 9. The days are 9 and the wind blows like this. That means on the 5th day the string is going to be like this. On the 5th day will move upward. On the 6th day the ship will move towards right. On the 7th day it would be like this. On the 8th it would be like this, while on the 9th day it would again move to the upward direction. So this string will repeat for the next 4 days, again for the next 4 days, and so on. Okay, so this is what I am calculating here, the cycles. That can be calculated by simply dividing the length of this string. So I have 9 divided by length is, let's say, 4. It is going to give me 2. So 2 complete cycles, that which is clear from this definition. We have to take complete 2 cycles of this forecast string. Okay, because it is given in the problem statement that the forecast is periodic. Then we have an extra days that will be represented by n modulo 4 when the ship will move, which is calculated by this variable rem, mid modulo n. Now what I will do is, now I have the number of cycles. Now I have the number of days, the total number of days in which my ship is moving. I will calculate the final position. This is the initial position of the ship, x position. This represents the position of the ship in these remaining days due to the wind. So due to the wind, this will be the final position. This will represent the number of units the ship will move in these remaining days, and this basically represents the number of units the ship moves in the end days, and multiplying this by cycles will represent the motion of the ship, the final position of the ship after the ship has gone over these many number of cycles. Okay, so this is just I'm just calculating this due to the wind. Okay, we have, so if I just go over the given parent string exactly once, this will represent the final position. While we have to move over the string multiple times, cycles number of times, if I multiply this unit by the number of cycles which I have to go through, I would get my final x coordinate after moving through these many number of cycles. While I also have to move these many number of days extra, which can be calculated by adding this to the x coordinate. While sx is the initial coordinate, we will calculate the same for the y coordinate. Initial coordinate, the number of units the ship moves towards y direction due to the wind in these many number of days, remaining number of days, plus the number of units the ship moves towards y direction in these many cycles if the ship moves this many units in one cycle. We have the final positions in x direction and in y direction, and this is going to give me, fine. Now I will calculate the difference between the final position, that is ex, and the current position in x direction, and the difference between the final position ey and the current position y in y direction. And this is going to give me the Manhattan distance which I still has to cover, and that I have to cover just by using the ship's engine or ship's power. Fine, because I have already covered this much distance from this sx to sy till this x and y. This is the remaining Manhattan distance. Okay, now since in one day I can move one unit of distance, in mid number of days I can move mid number of distances, be it in x direction or in y direction. Now if the number of days that I have guessed is greater than equals to the distance which I have to cover because of the ship's using the ship's power, then that means this mid lies on the good side. So reinitialize the range to left half, otherwise this mid lies on the good side, and reinitialize the range to the left half. So in this case r crosses the 5 into 10 raised to the power 12, so this is a kind of upper limit. If it basically crosses this upper limit, so I can never reach the destination node, I can never reach the destination position. In that case I will reinitialize the r to -1, so I will print the r, or r will basically store the number of minimum days which the ship takes to reach the destination. In case it can't reach, I will get -1 here. Fine, so in this fashion the function is working. Let's discuss the time and space complexity. We can see that the time complexity would be big of n because I am performing binary search over a specified range from 0 to this constant number. So log of, okay, so it's basically log of 10 raised to the power 80. So this would be the time complexity, while this n represents the traversal of the string, the forecast string initially, which we traversed here at this point. Okay, while the space complexity is constant, or not, the space complexity is not constant. We are taking, let's say it's big of n, where n represents the length of the forecast string, because I'm using that array d to store the final position of the given ship on the ith day because of the wind. So this is the space complexity big of n. So that's all for this. Let's jump to the code implementation part. Okay, so this is the solution class. Let's represent a function. Let's take long, and let's call it function minimal days, which takes in the initial position sx xy sy, ending position as ex ey, and the forecast string s. Let's calculate the size of this forecast string. This is the string which will basically say, let's say, direction string, which will be upper, down, left, right. And let's define the direction vectors dx to be 0 0 minus 1 1 and 0 1 minus 1. Let's declare a pair. D, which has a, let's take a very large number. Okay, so this is going to store the final position of the ship due to the wind. So just iterate over this forecast string. Now let's say id, take an id variable, initialize to -1, iterate over the direction string, and if in the direction string we match with, if the position at the if the direction at the ith position matches with the direction at the jth position, then that is going to store the id. So here if the id is negative, that means I just break right there. So if id is -1, we break out of this loop. Otherwise I just store the position on the nth day. That would be initial position plus initial position in the y direction. Okay, so in this fashion I will have my final position range L2 0, R2 1E 18. Run the usual binary search R minus L greater than 1. Find the middle element, that would be L plus R divided by 2. So let's take it long. Let's calculate the cycles. Cycles would be nothing mid divided by n. Remaining days would be mid modulo n. Now find the final position, find the final coordinate. So since we are standing, we start from this location, that is sx, plus the position in rem days would be this first, plus we have cycles, we go over these many number of cycles, and in one cycle we have this distance. In the same fashion we would take sy plus d rem dot second plus cycles modulo multiplied by dn dot second. Okay, the Manhattan distance, the remaining Manhattan distance, let's call it dist. It would be nothing but absolute of x minus the ending x plus absolute of y minus the ending y. Check if this distance less than equals to mid. If it is, reinitialize the range to mid, to the right, to the left half, otherwise to the left half. Okay, finally check if this r is greater than equals to, let's call it, let's say 1e17, then that means we can't find the desired answer, so return at the end. what we have here to be. So return the number of minimum days that it takes to reach the final destination. So in this fashion, this minimal days function is working. So this is the implementation in C++. Let's see the implementation of the languages. So that's all for this video. If you like the video, then hit the like button and make sure to subscribe to the channel. And we're just about to end this series, so stay with me. So I hope to see you all in my next video.